Assalamu alaikum guys, welcome back to math class. Today we are dealing with the last lesson of the chapter. Inshallah, pretty soon we need to schedule a quiz, most likely sometime next week, possibly Thursday, but I haven't decided on that yet. And then the following week after that, maybe a test. We still need to work on a study guide, we need to review, we need to make sure that you are getting all the concepts. So today we're dealing with Pythagorean theorem. This is lesson 5.7. It's going to be a one-day lesson. So we're going to apply it to real world problems. So remember, Pythagorean theorem is something we've done in 8th grade. It only works for right triangles, and the formula is a squared plus b squared equals c squared. So from previous year, I've shown you a right triangle with the a and the b being interchangeable. It doesn't matter what position they have. You can plug it into the formula. And remember that the a and the b always are the legs of the right triangle, and they always form the right angle. The most important value is your c, which is your hypotenuse. Hypotenuse is always across your right angle, and it is always the longest side. And that's the most important side because you need to place that value in the correct place value, or rather, correct position of the formula. Now, let me switch you to this board. And your instructions are to find, sorry guys, I'm dropping you, but find the missing measure and answer to the nearest 10 if necessary, okay? So sometimes you'll have an image, other times you will not. So in this case, they gave you a is equal to 3 and b is equal to 7. So go ahead and substitute your values. 3 squared plus 7 squared equals c squared. And then 3 squared is 9. And 7 squared is 49. So 9 plus 49 is equal to c squared. So we can say that c squared is the sum of 49 and 9, which ends up being 58. And this is the easy part of the lesson, guys. So remember, in order to unsquare that c, you have to find the square root of 58. So go ahead and plug it into your calculator, and you should get c is approximately 7.6 units. Don't forget your approximate sign, and don't forget your units. All right, the two squiggly lines on the approximate. So I'm going to go ahead and now give you another example. Let's say, for example, I give you that the value of a is equal to 5. The value of c is equal to 9. Go ahead and stop the camera, the video, and solve the problem and work on it. I'm going to go ahead and continue with it. I'm going to come back and erase some of this work up here and do the math problem for you. So go ahead and work it out on your own, then come back and check in. Did you get the correct answer or not? So I'm going to keep that a squared plus b squared equals c squared, and I'm going to plug in my values that I gave you down here. So my a is 5. I'm going to square that, then I have b squared, and then my value of c is 9 squared. So I know that 5 squared is 25, b squared, and then 9 times 9 is 81. All right, so I still need to isolate for b. I need to get rid of that 25, and in order to get rid of that positive 25, I need to subtract 25 from both sides. So now I'm at b squared is equal to 81 minus 25. You should get 56. Now, in order to unsquare the b, remember you have to find the square root of 56. And from the calculator, you should be able to tell what the nearest tenth in that is. And it is talking about 7.5. Don't forget your units. You were not given units on this, so your final answer should be b is equal to 7.5 units. So I'm hoping that you got it correct. Now, the next part we've also done in 8th grade. I don't know if you remember it, the Pythagorean triple. The Pythagorean triple is when you test if certain given values will create a right triangle or not. And that means that when you substitute the values and you work it out, each side is going to balance out and equal to each other. If it doesn't, then we know it's not a Pythagorean triple. What is it called now? Converse of Pythagorean theorem. And the way I talked about it to you all last year was that it is the Pythagorean triple. So you might want to write that down, that it is also Pythagorean triple. And basically what it means, three units of measure that are given to you, you test them and you make sure and check out if each side balances each. But now the numbers are not going to be as easy as we were working with last year, guys. We're introducing radicals to this. So here we go. Let's say, for example, they give us 5 and then the radical of 5 feet. That's one of the measurements. That's your 8. The next value given is 10 feet. And then third value given is 15 feet. So where's my red marker, guys? Let's see. Well, I'll use the blue, I guess. Here we go. So this is my value of A, this is my value of B, and that's my value of C. So go ahead and do your A squared plus B squared. And actually, I'm going to have to switch it a little bit to the side because I'm going to have to do some math when I get to the problem itself. So again, A squared plus B squared equals C squared. Now go ahead and substitute 5. Radical 5, that's going to be squared, plus 10 is going to be squared, 15 is going to be squared. Now this is the one that you have to be careful with. So I wish I had my red marker. I don't know where it went from the previous lecture, but I'm hoping that you see the difference between the red and, the blue and the black. So I'm going to be working on this part of the problem first, guys. So I'm going to basically 5 radical of 5 squared means 5 radical 5 times 5 radical 5. So this goes a little bit into what we were doing in the previous lessons. Now remember that I've got 2 5s sitting on the outside. So 5 times 5, and then in the radical I have 5 times 5. So 5 times 5 on the outside is 25. And then I have one set of 5s on the inside. I'm going to pull out 1, and then 5 times 5 is 125. So this value right here is 125. All right. Now 10 squared is 100. 15 squared, plug it into your calculator. 15 times 15 is 225. Then go ahead and add 125 plus 100 is 225. And then obviously the other side is 225 as well. So is this a Pythagorean triple? Are these measurements a Pythagorean triple? Yes. All of them worked out and it equal to each other, which was 225. I'm going to give you a problem for you to work on. I want you to go ahead and pause the video, and I want you to go ahead and check that the numbers that I'm giving you are working out. Y'all are probably going to say, Missy, then you already gave us one that's yes, so most likely the other one's no. You still have to show me the steps that you are able to get to the answer, not just because that's what you're guessing I'm going to do. So let me show you the next step. And that's why I hate using blue, because it stains my board, but what can I do? So here we go. Our values, the value that I'm going to give you in a minute. The first one, let's see. The first one is again a radical, and that radical is going to be 7, radical 2. Okay. So 7, oh goodness, 7, and then radical of 2, and we're talking about meters, and again that's your A. The next value is going to be 12 meters, and then 16 meters. Go ahead and stop the video, guys, work it out, and then come back to see if you got exactly the same answer that I got. I'm going to continue with it so I can finish it, and then you check in what happened with the problem. So here we go. 7 radical of 2 squared plus 12 squared is equal to 16 squared. Now remember, go to the side and you have 7 radical of 2 times 7 radical of 2, because that's what the square means. 7 times 7, remember, 7 times 7, and then in the radical you have 2 times 2. So 7 times 7 is 49, and then I'm pulling out one set of 2's and multiplying it to that 49. So it should give you 98, and I hope that's what you got. So I've got 98 plus 144, and then 16 squared is 256. So go ahead and add 98 and 144. It should give you 242. And we know that 242 is not equal to 256. So in this case, it is not a Pythagorean triple. So you would put a backslash through the equal sign and write no. So that part is easy. Now what I want you to do, I have uploaded this worksheet, okay? It's part of your notes. You don't have to print it out, but just understand that the next 2 problems that we're going to be working on deal with this worksheet. So you've got finding the length of a hypotenuse. So the hypotenuse, remember that it is a diagonal. So I'm going to want you to figure it out. So I want you to read it for yourself. And maybe some of you already read it. But you're being asked to find the hypotenuse, and you're going to have to answer 2 different ways. One of the ways is going to be in simplified radical form, and then the other one, which is the easy part, is to answer to the nearest 10th. So here we go. Your family is using 2 different sizes of square tiles to redo the kitchen's backsplash. If a diagonal is cut on each of these tiles, what would the length of the hypotenuse be? Give your answer in simplified radical form and as a decimal rounded to the nearest 10. So instructions are on the sheet, so I'm not going to spend the time writing the instruction on the board, but I'm going to go ahead and semi-draw the tile, and what you have is that 6 inches, and then it's asking you what is the diagonal. The diagonal, or the hypotenuse, is the distance from one corner to the other, and you know that you can see the right angle right there. So, although it's usually in red. So first thing you're going to do is go ahead and start with a squared plus b squared equals c squared. So a squared plus b squared equals c squared. Now being that this is a square tile, we know that all the side lengths are congruent. All the side lengths are 6 inches. So my a and my b are both 6. So plug in your 6 on both a and b, start doing the math. 6 squared is 36. Again, 6 squared is 36. And it'll equal to c squared. So we can say that c squared is 36 plus 36, which is 72. Now, in order to undo the square, we need to find the square root of 72. Go ahead. That is not a perfect square, so you're going to have to go back to the techniques that we learned in previous lessons, and you're going to have to take that 72 and you're going to have to break it down to its prime factors. So 8 times 9. Now the 8 breaks down to 4 times 2. The 2 is a prime factor. Take it a little bit further. The 4 breaks down to 2 times 2, and then the 9 breaks down to 3 times 3. So c is equal to, and you put the radical of, and I have 1, 2, 3 2's. All right, so 2 times 2 times 2. And how many 3's do I have? I have a total of 2. Go back. How many sets do you have of each? You have 1 set of 2's and you have 1 set of 3's. So c is equal to 2. Remember, I'm pulling out 1, 2. I'm pulling also 1, 3 out. What's left in the radical? The 2. All right. So c is equal to 6, radical 2, and what are we talking about? Inches. So this is my answer in radical form. Okay? Now, in order to get to the nearest 10th, go ahead and do the square root of up here, which is C is equal to the square root of 72. Plug it into your calculator and you should get approximately 8.5 inches. So this is your second answer. So at this point, I want you to go and do the second tile on your own. Pause the video. I'm going to start setting it up, and then I'm going to start solving, and then come and check and see if you got the same answer that I did. So here we go, guys. Again, read the question. More than anything, what's important, especially in this lesson, is that it's a square. Because one of the common things that kids will do, since it's a square, they try to divide by 2, and that's not going to work when you're trying to find the radical. So I promise you that this is going to be a question on test day, okay? And just to remind you, it's going to be about a garden. So here we go. This is 4 inches. That's for the second tile. So we know that both sides, all the sides, actually all 4 sides are 4 inches. So 4 squared plus 4 squared equals c squared. And then 4 times 4 is 16. 4 times 4 is 16. And then c squared, right? So then you've got 16 plus 16. And a lot of this, by the way, can be done without a calculator. C squared is 32. And remember, in order to unsquare that c, find this radical of 32 or the square root of 32. Now, 32 is not a perfect square, so you're going to have to go back, break down your 32. What 2 factors give you 32? I know that 4 times 8 gives you 32. The 4 breaks down to 2 times 2, and then the 8 breaks down to 2 times 4, and that 4 breaks down even further to 2 times 2. So the radical of 32 is 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5. Then go back, guys. How many sets and how many pairs do I have? I have 2 sets of 2's. So c is equal to 2 times 2. And what's left in the radical? Don't forget that 2 that's sitting way out there. Radical of 2. What's 2 times 2? 4. We've got radical of 2. And then what are we talking about? Inches. So final answer in radical form is 4 radical 2 inches. And then remember, come back to the problem, plug that into the calculator, the radical of 32. And it does say to the nearest tenth, if necessary. And in this case, if you plug it in, you should get approximately 5.7 units. So, inshallah, you found this lesson not as hard as the previous one. I think the previous lesson was a little harder. Yes, it takes a little bit of comfort to deal with a radical in Pythagorean theorem, or when you're doing the Pythagorean triple. I think the Pythagorean triple, when you're testing, if you have 5 radical of 2 squared, coming up with the answer to that, maybe it's a little bit more challenging, but it's not impossible. I think you all can do it. Inshallah, if you have any questions, don't forget to log on into class, and we will answer any questions you can. Don't forget to answer your daily question. So far, you all are doing a good job, and inshallah, soon I'll start grading some of your assignments. Hope to see you tomorrow, guys. Assalamu alaikum.